Hello, welcome to episode 2E. This time we're going to be talking about the final case. So, this is final. The final case where we have R1 is equal to R2. So, we have this equation, and then we could write the whole thing and then do the stuff, but I already told you that we are going to get two roots where R1 is equal to R2. So, what does that mean? Well, we take our quadratic equation, b squared minus 4ac there we go. If these are the same, this is the same when this is equal to 0, right? So if you remember from basic class, if we have something like this, our discriminant is going to be 0. So r is going to be equal to minus b over 2a. Forgot to say, right? So, and then that's going to be the only roots, right? So this polynomial is going to factor into pretty much r minus b over 2a squared. So what do we get from all of this? Essentially, this so when we go to write this down, obviously we're missing a solution. So we have y equals c1, so y1 plus c2, y2. And we have one solution here. y1 is equal to, well, e to the rt, or e to the e to the power negative b over 2a times t. But we're not really, but we're missing some, I'm missing this y2. So what are we doing for this y2? So the best way to think about this with this y2 is that y2 is going to be some function, okay, x of t times y1, right? And y1 is going to be, so this is going to be e to the rt, and these are going to pretty much vary by a constant factor. We can go through this whole process, and what we'll find is, so we take the basically what we're going to find is going to be some linear term. So x is going to be t plus 1, and this is not too hard to work out for yourself actually, if you essentially write the equation as it's not too hard to write if you actually go in and you take the second derivative and first derivative and things like that. But you're eventually going to come to this point where you're going to find that x of t is equal to some constant t plus, some d, right? So you're going to get this. And so when we plug that in, we get c1 of y1 plus c2 times ct plus d y1. And so what happens here? So we get c1 plus c2d of y1 plus c2 big ct y1. And this is, okay, so this is just another c1. This just becomes its own c2 there. And we end up with y is equal to, I'm going to write it in red, it's equal to c1 y1, or c1 e to the power of negative b over 2a plus c2 times t e to the power of negative b over 2a, and then obviously this is a function of t. So and so that's our solution to when we have two equal roots. Might not go over an example, but it's pretty much just plug in into this formula. Next, we're going to look at non-homogeneous solutions. It's going to be episode 3. Non-homogeneous solutions to these types of equations. And yeah, so see you then.